To begin, AWS clients send requests to the Application Load Balancer, and the Load Balancer routes them to instances grouped by service. Each instance in a service is called a target, and the service is called a target group. Here, we'll use a diagram similar to the one in AWS documentation that you're familiar with. Because of dependencies, you typically configure components in reverse order to traffic flow, that is, back to front. And here, we'll focus on HTTP traffic to save time and expose you to a wide range of features. To configure an application load balancer, you create target groups and register instances with your groups. Each target group has a port and health check, which allow it to function as a monitored service. When you use an auto-scaling group, you attach it to a target group and it registers instances for you. However, there is no way for the target group to automatically tell the auto-scaling group to maintain a % of total load balancer traffic. You also create listeners to check for connection requests from clients, and listener rules to route requests from clients to targets in one or more target groups. Each listener has an inbound port and one or more rules that map URL paths to specific target groups. This lets you define path-based routing to specific microservices or containers that are often on different ports. Here, the listener on the right splits traffic to orders and inventory paths into two different service ports and target groups. You can also combine services on a set of targets by including them in multiple target groups. This can save runtime costs by including, say, a CPU-intensive service with a memory-intensive service. And this is why listeners' rules allow you to map path-based URLs to different ports, because different services running on the same host commonly split their traffic by port. After you specify a target group and a rule for a listener, the load balancer continually monitors the health of all targets registered with the target group. The load balancer routes requests to the registered targets that are healthy. Note that each target group is bound to an availability zone. The load balancer, target groups, and auto-scaling groups are associated with a VPC, which is bound to a region. We will see in a minute that GCP load balancing is a global resource that can span all regions. Now let's look at GCP load balancing. In addition to what AWS offers, it's a fully managed service that runs in networking software. There's no process or warm-up time. You can deploy instances in multiple regions, and it automatically directs traffic to the region closest to the user with capacity. It offers several types of load balancing, and each has benefits for particular cases. HTTP, SSL, and TCP proxy are for external global requests. They include external global IPs and a proxy that terminates connections near users before routing requests to back-end services. This gives them global reach, cross-regional failover, and shorter latency. HTTP load balancing receives traffic on ports 80, 8080, and 443, and provides content filtering based on URL hosts and paths. TCP and SSL proxies receive traffic on any port, but do not provide URL filtering. Network load balancing handles additional TCP-based protocols, such as SMTP traffic, with the ability to inspect connection-related characteristics. Internal load balancing only receives traffic from internal network instances for better security.